Hello, and welcome back to another video with It's Dr. Dan, and today we're going to be learning how to find percent composition by mass, which the whole entire idea behind this is something that allows chemists to find the amount of an element within a given compound. So it allows us to be able to figure out essentially how pure a substance is. Now, the way that we're going to look at this with percents is just like any other mathematical steps, is that a percent is the part over the whole. Or more specifically, we're going to be assuming that we have a 100-gram sample and trying to figure out, well, how much of it is within that sample. So let's take a whole look at this. So what we're going to be using is the following formula. So what this is the mass percent is the total of a given element. So how much that mass there is using the molar mass and then dividing that by the molar mass of the compound times 100%. So this is a formula that we're going to be using throughout this entire video, going through multiple different examples of how you can calculate percent composition and how you can figure out how much of a sample you have with a given mass as well. So we're going to go through several different examples, and let's try to take a look at 3 easy steps for how we can do these types of problems. So with empirical formulas, the great thing about it is that there's 3 simple steps for how to do every single one of these problems. The first thing you're going to do is find the total molar mass of each element within the given compound, meaning that we have to count the number of atoms of each type. So if there's 2 carbons, we got to make sure we multiply our molar mass of carbon by 2, for example. Our second step is we need to find the molar mass of the entire compound as a whole, being that that is going to be the denominator of our formula. Last step is you just plug it all into your formula, and that is what we're going to be doing in all these different examples. Let's go into an example that we can do together, and as you're going through these, please feel free to try to pause it and try to do them on your own to see if you can do them as well. Okay, let's do the following problem. So it says calculate the percent composition by mass of C and O in CO2, which more specifically is carbon and oxygen. So let's go through it. Well, our first step was for us to be able to calculate the amount of molar mass for each element within the compound. So the first thing you're going to have to do is look up the molar masses from the periodic table, which I did for us for this problem. So if we have our compound, which in this case is CO2, what we have to do is count the number of each atom to calculate what the total mass is for each element. So for example, in CO2, I have 1 carbon atom. So what I'm going to do is multiply that 1 by its molar mass. So if I do 1 times 12.01 grams per mole, I'm going to get 12.01 grams per mole. Now, for oxygen, right, what are we going to do for the other portion? Well, with oxygen, we need to count both atoms, right? We have 2 atoms of oxygen. So we'll take 2 times 15.99 grams per mole, and that's going to equal 31.98 grams per mole. So that is for the first part. Now, for the second step, what we're going to do is we're going to take those values and add them up to find what the total molar mass is of our compound. So if we add up both these values here, we're going to get up our molecular mass. So our molar mass for the compound, so the molar mass of CO2 is going to be 12.01 plus 31.98 grams per mole. And what we will get in the end is 43.99 grams per mole for CO2. Now, our third step is just taking all those values and plugging them into our formula. So let's first do for the first one, which was carbon. Okay, so with carbon, we had a value of, so let's write down our elements. We have carbon and we have oxygen. So carbon had 12.01 grams per mole in CO2. And all that was over 43.99 grams per mole. Now, what we will do is we're going to multiply this by 100% in order to get our percentage of carbon within our sample. So when we do our math here, what we are going to get is 27.32% of carbon. Now for oxygen, we're going to be doing the same general thing. And keep in mind, all of these different elements that you have, the total should equal 100. So there's always a way for you to double check as well. So when we do the math here, we should get 31.98 grams per mole, right? Which was the part over the whole, which was the 43.99 grams per mole, what we got in part 2, times 100. And what we are going to get is 72.68% for our final answer. So when we see CO2, 27.32% makes up carbon and 72.68% makes up oxygen. Let's try to do another example just like this one. For the second example, what we have is ammonium nitrate, which is NH4NO3. And this is used as a fertilizer to add nitrogen to soil. And what it asks you to do is calculate the percent composition by mass of N, H, and O of the compound. So exactly what do we need to do? Well, if you remember, our very first step is to find the total molar mass of each element. So here I have our little handy dandy periodic table, just with each element already found for us. So we need to count every single element that exists in a species. Let's first start with nitrogen. So nitrogen, when we look at the formula for this particular element, we see that we have 2 nitrogens in the compound. There's 1 and then there's 2. So with these kind of compounds, we need to make sure we count every single element in order to make sure we count it correctly. So if there are 2 of them, what we're going to do is take 2 times its molecular mass, which is 4.01 grams per mole. And that total is going to be 28.02 grams per mole for nitrogen. Now we got to do the same thing for oxygen. So being that we have 3 atoms of oxygen in this formula, so we have oxygen and we have 3 of them, that's going to be 3 times 15.99 grams per mole. And that's going to equal 47.97 grams per mole. Now, when we go through this again, right, we now count how many hydrogens there are this time, and we can see that there's a total of 4 hydrogens that are within this formula. So we'll have to take that number 4, times it by 1.008. So now that will give us the masses for each individual part, which will help us feed into how much of each percent do we have. So it'll be 4 times 1.008, which is 4.032 total grams per mole for this species. Now, the good thing is about this is by counting all these elements, this allows us to figure out exactly what the total molar mass is of the entire element. Because what we're going to do is we're going to take all these values that we have here and we're going to add them all up. So we'll take that 28.02 plus the 47.97 plus the 4.032. And what we're going to get is the total molar mass here. Okay, so when we do that, we'll get a total mass of 80.02 grams per mole for NH4NO3. Okay, so that is the total molar mass. Now, what is step 3? Well, step 3 is taking these individual values and plugging them into our formula. So let's do that for ourselves. So let's blow up that formula so we can make it a little bit bigger so we can remember exactly what we have to do. So we need to take the total mass of each individual element. So let's first start with nitrogen. So nitrogen had 28.02 as its value. So 28.02 grams per mole. And let's move that over just a little bit. And what we are going to do is we're going to divide that by the total, which was 80.02. And the whole thing is going to be multiplied by 100 in order to make it as a percent. Now, when we go through that, we should get 35.02% for nitrogen. Now for oxygen, we're going to be doing the exact same steps, right? We take our partial mass, which is the 47.97 we see up there in red all the way at the top. So we'll take that 47.97 grams per mole, and we're going to divide that by our 80.02 grams per mole, and we'll times that by 100%. I'll put that on the left there just to kind of show the whole thing. And what we're going to see is oxygen is the biggest portion of this, and we will get 59.95%, okay, for that. Now let's also shove in hydrogen in here somewhere. So hydrogen we'll do as the last step, and that has a part of 4.032 grams per mole, which is all the way on the top right of your screen. And we are going to divide that by that 80.02 grams per mole times 100. Okay. Now, when we get that last percent, what we're going to get is 5.03%. Now, to kind of make sure that before you turn in any of your work to a teacher for assignment, you kind of highlight or box them to show every single one of those percents. So we use the same formula for each percent. Let's go on to our next problem to show another example of this, and it'll be our last one. Okay, so the following problem in our last example, it says the formula for rust is Fe2O3. How many grams of iron are in 22.8 grams of rust? So this one's a little bit of a stoichiometry problem, but this is something that will help you figure out how to use empirical formulas. So we only need to find how much the mass percent is of iron in this case, right? So what is that mass percent? So let's go through it with our first step, right? Which is find the total molar mass of each element, which we have the molar masses here, but we only are interested in iron, but we still need to do both pieces to find what the total molar mass is, which is step 2. So our very first part is being that we have 2 iron molecules, so we have 2 of them because of our subscript. That means that we have Fe2O3. We're going to take that 2 times 55.85 grams per mole, and we are going to get, when we do that math, is 111.7 grams per mole of iron. Now the second part is oxygen, and we have a subscript of 3 in this compound. So we have 3 times 15.99 grams per mole. And we are going to get a value of 47.97 grams per mole for our answer for that part. Okay, now step 2, we got to find the molar mass of the whole entire compound, meaning that we have to add up both of the values that we just calculated. So we got to add up the 111.7 plus 47.97. So let's rewrite that. So it's 111.7 grams per mole plus 47.97 grams per mole. Now, when we do that math, what we are going to end up getting is 159.67 grams per mole of iron, of Fe2O3 of our species here. So that is your total molar mass. Now, the last step is to find the percents. Now, which 2 values do we need? Well, we are interested in iron in this particular one. So when we go through our last and final step here, in order to find the portion of iron, that value before was 111.7. So we'll take that 111.7 grams per mole of iron, which is our part, and we're going to divide that by the 159.67 grams per mole of Fe2O3, times that by 100%. And what we're going to get is 69.96% of iron in this sample. Okay. Now, how does that apply to a mass sample? Well, what that allows you to do, this is a conversion term that we can use to be able to figure out, okay, how much iron is there in a given sample? So let's take a look. What was the original value? So we were given that we had 22.8 grams of rust that we collected in our sample. So let's go back down here and try to see exactly how can we use that. So we had 22.8 grams of Fe2O3. Now, a percent is the same thing as saying out of 100, right? For every 100. So the way that we can use this thing to our advantage is saying that, okay, I have 69.96 grams of iron all over 100 grams of Fe2O3, right? Percent out of 100. So this is a conversion term that you can use to cancel out grams. Now you can also simply just multiply the sample by the decimal value too, which is that 0.6996. You'd get the same answer. But it's good to be able to see how this works as a dimensional analysis or a stoichiometry problem, being that you always have to show your work in all classes. So when you do this, right, you multiply what's on top and then divide what is on the bottom, and you will get 15.95 grams of iron are in this sample. So this would be your final answer for the problem. So you can use these different mass conversion or these mass compositions for different purposes. So I hope that this video helps so that way you can see how to calculate these to be able to solve these on homework. Now, for most of you, this is for all chemistry students. This is usually one of the most common types of exam questions that you see on exam 1 or exam 2 in most general chemistry and introductory chemistry classes. So make sure you're familiar with them. And check out my follow-up video to this on how to calculate an empirical formula using the percents. Okay, and I hope to see you all next time. Thank you so much for stopping by. Please hit that like and subscribe button, and please comment below if there's different videos you'd like to see in the future. All right, bye now.